Chemical symbols. So as we start to learn chemistry, you have to get familiar with the chemical elements. And what we're going to find for any chemical element, X, there is no element X, this is just a placeholder. We're going to find that for any element, there's going to be a Z number, and this is the atomic number. The atomic number is the number of protons in an element. This defines what the element is. And I'll give real examples in a second. So this number of protons defines what the atom is. Is it hydrogen? Is it cobalt? Is it lanthanum? The A number is the mass number, or atomic mass number, and it's actually the sum of the neutrons and protons in that particular element. So it's the sum, it's the number of neutrons plus the number of protons. Hydrogen has one proton, that's what defines it as hydrogen, and it has 0 neutrons. However, there's another form of hydrogen that has 1 proton and 1 neutron. In the case of hydrogen, the isotopes have special names. An isotope is the same type of element, but with different numbers of neutrons. We would call this hydrogen. This we would actually call deuterium. And there's a third form of hydrogen, which has 2 neutrons, but also 1 proton. Again, otherwise it would be a different element. This is tritium. So the 3 of these would be referred to as isotopes because they're all hydrogen, all have 1 proton, but they have a differing number of neutrons. In your textbook, proton, neutron, electron. You should get familiar with those 3 subatomic particles. Proton has positive charge, the electron has a negative charge, and the neutron has a neutral charge. When we start adding and removing electrons, we'll get into ions. We'll look at charged species. So for right now, we're just kind of bootstrapping our way into chemical elements and symbols and so forth. So you can have isotopes of virtually any element on the periodic table. Not all isotopes are possible, but there are many examples. Boron. So now, when I write the symbol B, that tells me it's boron. When I look on the periodic table, I can see that it has a Z of 5 protons. If I leave this number off, it's implied that Z is 5 because it's boron. So the Z is actually redundant. I'm sure a lot of you were thinking, well, why do I need to write 5? If it's boron, by definition, it has to be 5. And you're right, it is redundant. But now what is not redundant is which isotope. Are we talking about B10, which has 5 protons, therefore it must have 5 neutrons, or possibly B11, which has 5 protons but 6 neutrons, right, if we're counting them up. And what we'll see is that as we look on the periodic table, that the mass number, the atomic mass number that's written on the periodic table is actually an average of these two numbers, but not a straight average, not a 50-50% average necessarily. It's a weighted average depending on natural abundance. And I'll address that later on. So again, as we're looking at the elements on the periodic table, and of course, these two would also be isotopes. Isotopes of boron, isotopes of hydrogen, not isotopes of each other. I don't want to get confusing about that. Maybe I shouldn't have drawn the arrow. So they're isotopes, but of each other. Elements are differed by the Z number, by the number of protons. So regardless of how many neutrons I have, if I have 5 protons, this is always going to be boron. In theory, this could be 12, 13, 14, whatever. As long as there are 5 protons, it's boron. And different elements have differing numbers of isotopes. Some elements only have one isotope that is stable, and we'll talk about what stability means later on. Other elements have a whole flavor of different isotopes. They have quite a few, 3, 4, and beyond. But again, we'll address that as we move through the periodic table. And again, looking at the elements, the mass number, the number of protons and neutrons, and the Z number, that's going to be something that we'll just get used to as we do more and more examples.